the button on the user interface.
Yes, now we can hear it good. So please start.
And then it will stop like we did last time. I'll just start the call here, but just, noises. I think you had 20 contacts, right?
Sound, my side is not good. Have a noise?
Oh, no, it's good.
Okay.
Oh, your sound is good, but you were saying that the sound was not good. Can you hear me correctly?
Yes, well, we can.
Oh, okay, so we're good.
Yeah, let's go on. Yeah, let's go on.
All right, so, hello, how are you guys today?
Yes, we have 3 people, and we welcome you for demonstration today.
Yes.
Yeah.
Refresh my memory here. Was this a wheeled or tracked vehicle that you guys need to simulate?
Yeah.
Is it a vehicle with wheels or tracks you guys are looking to simulate? Can you refresh my memory?
Because we focus about time simulation, so today you can demo for us for time simulation.
Tank simulation. Okay.
Yes. Military time simulation. We focus about Russian tank. So if you have any sample about Russian tank, you can show to us.
The only sample we have is something that comes with Vortex, and that's an M1A2, so I believe that's American.
No worries, let's go ahead with it. Yep.
Okay, so this is an example of a tank that we're delivering with the Vortex software. And so right now I'm loading it up inside of our editor, and as I go and run the simulation, we're going to see how we can have the tank move and be simulated in our environment. So right now we can see, of course, it's going to be a bit slower going over the internet. But
Yeah.
So what you'll see here is that we have the tank that we can simulate, and we are simulating the motion of the tank itself. We are also simulating the tracks that are moving about on the tank. Now I'm using a gamepad at the moment to be able to simulate the tank and accelerate, and then be able to brake and do things like change the steering mode, and then be able
Okay. Yeah.
to turn the tracks on either side. And so as we're doing this, we're simulating how the track is interacting with the ground. And of course, it's going to behave differently on different types of terrain. So we can define in Vortex how the materials of the track are going to be interacting with the ground below.
Hmm?
So now I'm going to go in an area where we have different types of terrain. So I was on a road. I'm going to go over to a different type of road. And then we have a section that actually has icy terrain. And so then we'll be able to see that as I get on the ice, the tank is going to get much slighter than he would normally, because now I'm on a very icy surface. So in Vortex, we can define all of the behaviors of the vehicle. And so the way we do this starts by modeling the machine or the tank itself that we're looking to simulate. Now, the way we do that first starts inside of our editor. And there we import 3D graphics from an external source. Now, you can load in a fully rendered 3D model like this one with textures that you would need to create using a tool like 3D Studio Max, or you can look at purchasing the 3D model for the vehicle you want to simulate. If you can find, there's many online stores that specialize in selling 3D models, and then you can import that inside of the Vortex tool. The other option we have to be able to load geometry is using CAD import. But in that case, the model would not be as pretty. So since you guys want to do training, you will need to look at getting a 3D model created or at purchasing a 3D model to be able to start the process of creating your vehicle in Vortex. Once you have the model, then the second part is to define all of the different mechanical components of the vehicle you're looking to simulate. So that includes defining elements such as the main body of the tank, the turret, and the cannon. Now for each of these, we define what's called the collision geometry. So that's these different shapes that we see here, these boxes and the bubble we have around the turret, and that will be used to detect how the vehicle is going to collide with other elements inside of the world that's being simulated. What we also specify when we're defining the different elements is going to be different properties like what is the mass of this element, and then where is the center of mass, and what is the inertia tensor. The inertia tensor is what's going to specify how the mass is spread out. So we can see this purple bubble is going to show us that the mass is kind of stretched out and distributed along the main body here of the vehicle. Now, after you define these different individual components, then you specify how the components are going to be connected with each other. And so this is done by using what are called constraints. So inside of constraints, we go in and we specify how the turret is connected to the body of the tank, and then how the cannon is going to be connected to the turret. So I can specify but what we also have is the actual definition of the vehicle. So here, if I look at my tree, I see that I've loaded up a flexible track transmission for a tank inside of this mechanism. And so in here, then I have a lot of information about all of the track wheels, the sprocket, the idler, that are going to be used to be able to simulate this system. Now, there are a lot of different parameters in here that are used to be able to define how the vehicle is going to behave. And that includes basic data about the position of the engine inside of the vehicle, information about the transmission. If you're simulating an automatic transmission, when will it shift gears to go up and down? Then we also have a section to be able to specify the different gear ratios. So based on the transmission, what's going to be the gear ratios for how the engine power will be scaled up or down. Then we have parameters for the engine itself. And so here, the way we specify engine parameters is using CSV files that will specify the torque table for the engine and the braking torque table. Now, if I take a look at where these files reside, what these are CSV files that are on the disk, and we give you a template to be able to create the torque table for the vehicle. So in here you can specify for different RPMs what's going to be the power output that's going to be produced by the engine. And so based on this information, Vortex will then be able to create a simulation that's going to be accurately modeling upshifting, downshifting, and how much power should be generated by the engine as you're controlling the vehicle. Now, of course, this is a tracked vehicle, so we'll have data here on each of the tracks. So elements like the brake scale, but also the sprocket mass, track elements mass. And so this kind of data will be used to be able to accurately model the track. And then we can then also specify where each of the wheels are going to be located on the vehicle model. We have some steering logic. So here, this has another table that determines how the vehicle is going to be able to steer left to right and what kind of forces should be applied so that the vehicle can move properly. Now, afterwards, if we look at things like the left track and the left track graphics, what these let us do is specify how we're going to render the track inside the environment. So we have different textures that can be used. So right now we're using this tank track texture. It could be replaced with a different texture if you need it to have a different look and feel. And so we'll then be able to have that track move around, and we can configure how smooth should it be and what kind of graphical rendering techniques should be used to be able to draw the track. Because if you notice here, in this 3D model, we don't actually have the track itself. The track is something that we generate dynamically at runtime to be able to be shown on screen. But it's not something that you do as part of your 3D modeling. Now, other tools we have inside of Vortex, as I mentioned, I'm using here a gamepad to be able to control the tank. And so this data is coming in through our USB joystick interface. So this is something that we provide that can read in data from a USB control and make it available inside of the Vortex simulation. So all of these yellow squares here indicate data from the joystick that I'm using and sending into the simulated tank. If I want to see where this data goes, I can use the button here to go and display the connection list. So this list here will show us all of the different flows of data between the joystick and different controllers or the joystick and the engine systems. So we have data that's moving about inside of our simulation. Now, speaking of controllers, to control things like gear changes or even to decide if the tank is in driving mode or pivoting mode, then we use Python scripts inside of Vortex to be able to control that logic. So these scripts can let us do a number of things, including
Bình thường nó có chọn là xem output sao và nó vào cái màn hình nào, vào cái nguồn nào.
Mình nghe gì? Hello?
Hi.
Oh,
Yes.
yes.
Are we good?
Now, yes, we have a problem about sound. So please continue.
Yes.
Yeah.
So where was I? I think I was explaining that Python scripting is very nice because you do not need to compile it. You just write the code in the editor. We have a little tool to validate the syntax, and then you run, and you're good to go. Let's see here. So In terms of simulating the vehicle itself, you can see right now we've defined different points for the camera. So is and orient cameras anywhere inside of the simulation. Then afterwards, when you're running, you can determine where you're going to be looking from. So right now, the driver, and then we have the gunner or commander view at the top. Now, in terms of the environment, what we have is terrain that's been loaded. So here we're loading geometry for the terrain. Now, when you load that terrain, you get to choose and configure what's going to be the default material for the terrain, and then you can create rules to identify other kinds of ground inside of the area. So for example, if we find 3D nodes that have the name rocks in them, we're going to make them of type road. If we find things that have the type road sand, then that's going to be sand. So all these different rules let us create an environment where we have different types of terrain that the user will be driving through. So now if I just run again and show you kind of the point of view from the tank driver, so I can see that I'm controlling this from the right, well actually no, not the driver point of view, I'm at the gunner position. But we can see how things would look from the gunner position at the top of the tank, and how we get all of the bumps and feels for the from the environment.
I think it's difficult to see. We should record it.
Now,
and send it.
once you've created the content, the simulation, then you don't always run it inside of the editor. Instead, we have a tool called the player that is used to be able to load that content. So using the player, I can come in and load a scene here. And let me see, defense vehicles. Why am I not? Oh, I forgot to export it. Export. There we go. There, right here. So now we can see I have the same kind of camera control with different cameras, and then I can go in and be able to use this to start to run the simulation. Now, so this player tool will load up the content that's been created inside of our editor, and this tool can run to be able to display one channel like we're seeing here, so one 3D view, or it can be used to render a complete simulator. You can have it displayed on multiple LCD screens, or even use it inside of a dome environment with projectors. All of that is running all from the same tool. Of course, if you're running on different things, you're going to be configuring different viewpoints to be able to look up, left, right as you're creating your full visual field for the operator. Now, in this application, all of the controls that we had in the editor are also going to be working. So the control. Controller that had no code in this.
Cái này trong là sao thu nó là cho mình download những cái model của nó có
Model 3D nó bảo là có store. Có store mình mua mình
không. Cái này có nằm trong cái sample kia của mình không? Hình như là có.
cái tăng này
Cái này có,
sample.
11A1 có trong sample.
Mấy cái file data của nó có.
Có. Nhưng mà phải cài được như đây.
ra đây trong cái
Tra được.
cái bộ phận đã bắn vào nòng súng. Đạn thì nó cũng chỉ là vật lý thôi, đạn thì không.
Nhìn được không moi được.
Moi mà còn yếu hơn. Đấy.
Hình này frame rate nó thấp mà.
Em nghĩ anh chắc là Sky nó sang vào đây thì nó đổi nó biết chứ đây khung màn hình của nó đây nó không hiện ra cho nó.
Đâu cũng để ý được mà.
Đây làm những cái chỗ
His
nào?
devices are not.
Yes, still connected.
Yeah, he's still connected, but if his speed dropped, then he's gonna have a hard time hearing us. He might only hear bits and pieces, or he might not see anything.
Okay.
We can hear now.
We can hear us. Yeah. Okay, now.
Okay,
if you have question- yeah.
When did you lose me? Do you need? How long ago did it stop working?
It's about 20 seconds ago.
Okay, so where was I? I was explaining that you can use C++ to integrate control devices that are not USB, or to be able to communicate with other applications, potentially other mechanical models or other tools that provide a C++ API. Plugins can also be used to do things like talk to a motion platform. So if you need to have a motion system for this project, we have already done work with systems from companies like Dbox and Moog. But if you need to support other kinds of motion systems, then it is possible to do so using a plugin. Now, other tools.
Lại đi thôi.
Tools we use to be able to monitor the current speed and the current RPM of that tank as it's moving about inside of the simulation. So I'll see here, I'm going to start to move forward, and so then we're going to see the RPM fluctuating and the speed changing as well as I'm running the simulation. Now, of course, in this case, the RPM values are much higher. What we see then is when we change gears, we're seeing the RPM go down as we go and we change gears. So all of that is being managed inside the tool and can also be seen and visualized. So this kind of information is what we use when we want to do data validation. So something a lot of our customers want, especially in defense, is to make sure that the vehicle is going to accurately reproduce the way that that vehicle works in real life. So based on manufacturer data, we use that information to be able to enter the torque data for the engine and the different parameters that I showed you earlier, and then we can produce data showing us acceleration times and different information about the vehicle and compare that against the real vehicle performance. And so that's how we can show our customers that the model we have created is accurate and is going to properly reproduce how that simulator works in real life. So at this point, I've kind of given you a good overview of Vortex and its capabilities. Are there specific questions that you have in mind about your project and the type of work you're going to need to do?
Oh, yeah.
Okay, so you finished for demo.
Well, I finished the main presentation, so now would be more of a discussion, or if you have
Yes, sir.
questions based on what you saw.
Yeah, okay.
We see that the mechanism of the tank is very complicated. So can you provide some support to us to building the mechanism of a specific tank?
Of course, there's two main ways that we can work. Either we can train you on how to use the tools, or what we do for a lot of our customers is we actually end up doing the main development of the vehicle for them. So, for example, if I look at Singapore technology, we do a lot of work for them, simulating different types of vehicles, and we're the ones who are doing the modeling. Same thing with Elbit in Israel, a big vehicle manufacturer, and they do a lot of simulation. And so we work with them to be able to model all the vehicles, and then they integrate that inside of their simulators. So that's one way we can go, is completely do the models for you. The other way is we give you training. Now, the way that training can be done is we can do it very tailored to your needs, where we would basically send someone to show you how to use the tools as you're building the tank. And so that would make you learn how it works. Now, to be able to do that type of training, we do need to spend some time developing the vehicle before we come to your facility. We can't just do it all from scratch there, because that would take too long. I mean, in general, for us to do a high accuracy model is typically around 4 to 6 weeks of work. Very complex machines can go up to 8 weeks. So if we're going to do training, we would have to do that work ahead and then come and show you how we built it, or we just build the whole thing and then deliver it to you online, and then you integrate that and do the rest of your simulation.
Okay, I understand. What if we want to develop the model by ourselves? And can you briefly describe which step do we need to follow to develop a mechanism for the tanks?
Well, you would still need to get some training, and we do offer general training to be able to show you the tools. You do get examples like this tank that I showed you as part of our sample kit, so that you can look at how it's been constructed, and then you can go through support to ask questions as you're trying to modify the tank to suit your needs.
Yes.
Buddy.
I have a question. Does the 3D models have impact on the simulation mechanism?
Well, you do need to have a model that is properly articulated. So in your model, you need to have put proper joints to be able to move things like the wheels, the sprockets, the turret, the cannon. So all of these elements in the 3D model need to have been identified as elements that have joints, meaning that they'll be able to move during the simulation.
Yeah.
The other thing to be aware of is in that 3D model, you do need to have created a model that is not ultra detailed, because if there's too much detail, that could slow down the simulation. So you need to make a model that's well constructed and doesn't have too many polygons, and that is properly broken down into the right hierarchy with joints, so that you'll be able to animate the model.
Yes, thank you. Can you tell
And we
me?
do have a guide that explains how to model, how to create 3D models, and that's something that comes with the software.
Yes, thank you. Can you tell me about the licensing?
So in terms of licensing, there's we first sell the editor with the player as the base set of tools that you would need. So the editor gives you access to editing capabilities for Vortex. Then you have one copy of the player that comes with the editor to be able to test out and deploy your content. Then afterwards, to deploy the simulation in each simulator, then you need to purchase additional runtime licenses for the player. Now, the way these licenses are organized, you need one license per computer that's going to be running the player. So, in your case, for your simulation, what kind of display system are you going to be using?
I think we need two kind of license for developing and for some time.
What kind of displays are you going to be using? Flat screen?
Display.
Hình.
Display.
Or projectors with a curved screen?
Display. Can use
Màn hình LCD.
LCD. We will show software to LCD screen.
I don't understand that word. Ashley?
LCD.
LCD.
Yes.
LCD. Okay. So LCD screens. So you're going to have two LCD screens,
Maybe more.
or many LCD screen.
Yes.
Many more. Okay. So the way we typically do our sims, we'll use one computer per two screen. So for every two LCD, you'll need one computer, and that computer will need to have a license for the runtime. Then you do need to have, good graphic cards in each of these computers. So we recommend the GTX 970 and higher from NVIDIA GeForce. So you do need to have good cards to get good performance on that system. And so, as I said, you'll need a runtime license per computer that you want to be running. The other thing is going to be, I believe they'll need a license for the vehicle system, but that's something that we can verify and send you in terms of pricing information.
Yes, thank you. Please send us the pricing information for the license.
Great. So I'll work on that with Aloysius. I'm currently traveling, so I'll see if we can get that done this week. Otherwise, it'll be early next week. We'll send that to you.
Yes. And before we discuss about evaluation software, I also download software of vortex. But now, can you send to me license for evaluation?
I think you already started looking into that with Justin. So Aloysius can follow up with him to see about getting that generated. Yes.
Sorry, we want to have evaluation software.
Right. So I know last week you registered on the portal, correct?
Đó là follow với thằng kia. Thằng anh Tuấn là ấy.
Ok rồi.
Okay. Yeah.
Oh, did you get your login for the portal?
Login there.
Yes.
Yes. We already logged in and download. But
Okay, so you're just missing the license at this point. Aloysius can just check with Justin and our licensing person to make sure that we give you proper instructions on how to get that license. It should normally just be something you can get for yourself on the portal after you get access. So if you've already gotten access and downloaded the software, Justin and Aloysius with our licensing person can make sure of what you need to do to get your license.
Yes, thank you.
Hỏi câu tiếp đi.
Anything else?
yeah.
I have another question.
Yep.
You show us that the engine parameter is imported from CVS file.
CSV, yes.
CSV. Yes. How can we obtain that parameter?
Well, the way it works, like I mentioned here, we have this Excel spreadsheet that you use to enter the data. Then afterwards, this spreadsheet data goes into these other sections that we can then look at exporting into a CSV file. Because here, let's see, if I look at something like the LAV BTT, we can see that it's just this small file. So the engine brake, and if I look, if I look at the tank one, so tank TT, that's the torque table, and then the engine brake is this. Now, if I look at the other file that I had before, we can see that we have this first spreadsheet, and then the other two tabs really just go in and give you kind of a smaller version of that, only the important data to be able to export it back out. We can provide you more details if you need at that time on how to go and enter all the information in here.
So if we want to simulate a specific tank, we have to measure the parameter by ourselves.
Either measure them or get them from the tank maker.
Okay.
Yes, there are also ways that, we do offer services where we can send someone with measurement equipment to use to measure the different performance curves of the vehicle. But of course, that means flying somebody over with equipment, and it does add cost to be able to do that. So the first thing would be to see what you can get from the equipment maker.
Yes.
Xong rồi chưa?
Nhưng mà cái mới cái này cái con nó có tách dùng đâu?
Không, tay là khác. Khác. Chứ không phải.
Anh hỏi xem có cái demo nào bắn súng gặp
Không, nó không có đây.
Không có. Cái trước bạn.
Thank you for your demonstration. I think we don't have any more question.
All right, thank you very much for your time.
Thank you.
Okay, I'm glad we were able to do the demo this time.
Thank you very much.
Yeah. Okay, Tuan,
Yeah,
can you hear me?
yeah, I can hear.
Okay. Let me talk to Justin and see what's the problem with your evaluation copy, and I'll get back to you.
Okay.
Yes, okay.
Okay. Yeah. Have a happy holiday.
Yeah. Goodbye.
Yeah, long holiday. Yeah.
Yeah,
Yeah.
thank you.
Okay, bye
Thank you
bye.
very much. Yeah.
Holiday happy à?
Happy holiday.
Happy holiday.
Thế tóm lại là hôm nay được cái gì rồi?
Quay được một chút.
Này cũng quay là mình cũng biết là cái form mà nó dựng một con tay này con cỡ
Nhưng mà không thấy bay
Mấy
trong
cái bánh nó thân
khung lái à?
cố định nào
Không vòng ngoài.